Hello everyone. Let's take a look at our next problem. Find the length of the curve given by y equals x to the 4 over 16 plus 1 over 2x squared, where x goes from 1 to 2. Okay, so the first thing I'm thinking is I need to remember what the formula is for the length of a curve when it's given in terms of a function of x like this. If I remember correctly, it'll be the integral between the endpoints for the values of x. Let's see, it'll be dy dx squared plus 1 under square root dx. So informally, what is the best way to remember this? Well, if I sketch what a curve might look like, something like this, over, if I want to compute the length between 2 points like this, informally, I have a dx squared and a dy squared. So L squared, well, let's write it as L, is going to be dx squared plus dy squared under a root, which if I factor out a dx squared, is something like this. So this is just, a mnemonic way of remembering what the formula for the length is. And then of course we have to add up all of these individual lengths as we move across the curve. So that's why we have to integrate over the range needed. Okay. So let's first compute the derivative. This shouldn't be too difficult. And then we need to square this. Well, I can simplify a piece here like that. So if I square this, I get x to the 6 over 16 minus 2 x cubed over 4 times 1 over x cubed plus 1 over x to the 6. And then I need to compute the derivative squared plus 1, which will be x to the 6 over 16 plus a half plus 1 over x to the 6. And I need to take a square root of this quantity. I suspect that maybe this can be factored. Let me come back to that in a second. But I suspect that what I have underneath the square root sign here is equal to something squared. Let me see. Yeah, this works. This is correct. Okay, so I've factored this thing under the square root, which means we're just integrating, at the end of this, we're just integrating something like this. So the length of my curve is going to be given as the integral from 1 to 2, x cubed over 4 plus 1 over x cubed dx. This should be a straightforward integral, so I'll go through the rest of these steps without commenting and hope I don't make any arithmetic mistakes. So this is what I've gotten as the final answer for the length of this curve, 131 over 8. Unless I've made some kind of simple mistake in my calculations. This really just boiled down to two things, I guess. The first is remembering the formula for the length of a curve. If you ever forget that, you can kind of go through this formal argument based on, dividing by differentials and all that kind of thing. And then it really helped to identify that the thing under the square root here can be written as something squared. That really helped simplify the thing that we're actually trying to integrate. Thanks for watching.